Hello, my name is Kaushik Reddy from CACB, and my topic for Dbms, the Ultimate Database Management System, is a data structures for fast region searches. So let's get started. So let's know what is searching, the basic definition of searching. So searching is a process of finding a given value position in a list of values. So searching is nothing but finding a given value in a list of values. It decides whether a search key is present in the data or not. It decides the algorithm process of finding particular item in a collection of items. It can be done on internal data structure or an external data structure. Searching techniques. To search an element in a given array, it can be done in the following ways. There are two ways to search an element in a given array. So first two ways are sequential search and binary search. So first, linear search algorithm. So linear search is also called as sequential search algorithm. It is a simple search algorithm. In linear search, we simply traverse the list completely and match each element of the list with the item whose location is to be found. If the match is found, the location of the item is returned. Otherwise, the algorithm returns null. It is widely used to search an element from the unordered list, that is, the list in which items are not sorted. The worst case time complexity of linear search is big O of n. So the steps used in implementation of linear search is called or is listed as follows. So first we have to traverse the array elements using the each for loop, and in each iteration for loop, compare the search element with the current array element, and if the element matches, then return the index of the corresponding array element. If the element doesn't match, then move to the next element. If there is no match or the search element is not present in the given array, return -1. So this is algorithm. So first linear search n and val. Val means value. A is the given array, n is the size of given array, val is the value of the value to the search. So step 1, set position is equal to -1, and step 2, set I is equal to 1. Step 3, repeat step 4 while I less than or equal to n. Step 4, if a array of I is equal to the given value, then set position is equal to I. Print position. Go to step 6, end of if. Set I is equal to I plus 1. End of the loop. Step 5, if position is equal to -1, print value is not present in the array. Next, end of if. So at the last step 6, exit. So this is the program. Define linear search values, comma search underscore for search underscore at is equal to 0, search underscore result is equal to false. Match the value. So while search underscore at less than the length of values and search underscore result is false, if values in the square bracket search underscore at is equal to search underscore for search underscore result is equal to true, else search underscore at is equal to search underscore at plus 1. Return search dash. So next, given input L is equal to given array is equal to 64, 34, 25, 12, 22, 11, and 19. Print linear search L comma 2L. Print linear search L comma 91. So print the 12 and 91 whether they are in the given list or not. So basically you can see that 91 is not in the given list and 12 is in the given list. So this is how the program works. Next, linear search complexity. Best complexity, average case complexity, worst case complexity. So the complexity of the linear search. Best case in linear search, best case occurs when the element we are finding is at the first position of the array. The best case time complexity of search is big O of 1. Next, average case complexity. The average case complexity time complexity of linear search is big O of n. Worst case complexity. In linear search, the worst case occurs when the element we are looking is present in the end of the array. The worst case in linear search could be when the target element is not present in the given array, and we have to traverse the entire array. The worst case time complexity of an search is big O of n. Next, the time complexity of linear search is big O of n, because every element in the array compared only once. So best case, average case, worst case. The time complexity are given. So the best case of the search is big of 1 and the average case is big of n and the worst case of the search is big of n. So we can say that average case and worst case of the search are both the same. That is nothing but big of n. And for the time complexity of best case is big of 1. Next, advantages of linear search. Easy to understand and no special data structures required. Easy to understand. Linear search is a simple algorithm that is easy to understand and implement, making it a great option for the beginners. It works by sequentially checking each element in a list until the desired element is found, making it a straightforward process. Next, no special data structure required. Next, the linear search can be applied to any data structure, making it versatile option. It doesn't require any special type of data structure like a balance tree or a hash table, which can make it simpler to implement. Next, can be used on unsorted data. Linear search can be used on unsorted data, which can be advantage in certain situations. This is contrast to other search algorithms like binary search, which require the data to be sorted. Next, no additional memory required. In linear search, doesn't require any additional memory to be used, making it is a more efficient option in a terms of memory usage. This is a contrast to other algorithms like hash table, which require additional memory to store the indexes. Next, not affected by the data size. So the linear search is not affected by the size of the data and can be used to search for elements in large lists. This is because the algorithm takes the same amount of time to search for an element, regardless the size of the list. Next, disadvantage of linear search. The time consuming. Linear search can be time consuming, especially when they're dealing with a large list. It checks each element one by one, which can take a lot of time when searching for an element is in a long list. This makes it less efficient than other search algorithms like binary search, not suitable for large data sets. Linear search is not as efficient as other search algorithms when dealing with large data sets. It can take long time to search for an element in a large list, which can be significant disadvantage when dealing with big data. Not suitable for ordered data. Linear search is not suitable for ordered data. Other search algorithms like binary search are more efficient when searching for an element in ordered data. Not suitable for repetitive tasks. Linear search can be time consuming and inefficient when used for repetitive tasks. It's not suitable for tasks that require multiple searches, as it will take longer to search for the same element multiple times. Not suitable for real-time applications. Linear search is not suitable for real-time applications as it can take long time to search for an element. This can be significant disadvantage in the applications where a quick response time is required. Next, binary search algorithm. Binary search is a search technique that works efficiently on sorted lists. Hence, the search an element into same list using the binary search technique, we must ensure that the list is sorted. Binary search follows the divide and conquer approach in which the list is divided into two halves and the time is compared with the middle element of the list. If the match is found, then the location of the middle element is returned. Otherwise, we search into either of the halves depending upon the result produced through the match. So this is the procedure for the binary search. A is the sorted array, n is the size of array, and x is the value to be searched. Set a lower bound is equal to L and set an upper bound is equal to n. While x not found, if upper bound is less than a lower bound exit, x doesn't exist. Set midpoint. Lower bound plus upper bound lower bound plus upper bound minus lower bound by 2. If array of midpoint less than x, set lower bound is equal to midpoint plus 1. If array of midpoint like greater than x, then set upper bound is equal to midpoint minus 1. If array of midpoint is equal to x, exit x found at location midpoint, end while. So this is the procedure how binary search algorithm or the program works. So this is a program. So first position is set, position is equal to -1. Define a search list, define a list, uh, like define a list where you want to search an element. L is equal to 0 and U is equal to length of list minus 1, while L is less than or equal to U, mid is equal to L plus U by 2. If list of mid is equal to N, global position is equal to mid, return true. Else, if list mid less than N, L is equal to mid, else U is equal to mid. List given input 478. So it is not a runtime input, it is a variable already the input is given. So 4, 7, 8, 10, 12, 45, 19 are the input and N is equal to 45. If such the search element is equal to 45. If search list 10, print found at position plus 1. Else print not found. So this is the basic program. So here the given input list is given 4, 7, 8, 12, 45, 99, and the element I want to search, or the search is 45. Then it is a position at 5. So it's found at 5. That's it. Next, binary search complexity. Best time complexity. In binary search, best case occurs when the element to search is found in the first comparison. That is, when the first middle element itself is the element to be searched. The best case time complexity of binary search is big of 1. The average case time complexity of binary search is big of log n. And the worst case complexity in the binary search, the worst case occurs when we have to keep reducing the binary search space till it has only one element. The worst case time complexity of binary search is big of log n. So the best case, average case, and worst case for the binary search are as given that the best case is big of n, and the average case is big of log n, and the worst case is big of log n. So both average case and worst case are same. That is big of log n, and the best case is big of 1. These are the time complexities of binary search. Next, advantages. It is better than the linear search algorithm. Its runtime complexity is big of log n. At each iteration, the binary search algorithm eliminates half of the list and significantly reduces the search space. The binary search algorithm works even when the array is rotated by the some position and finds the target element. Next, disadvantages. The recursive method uses stack space. Binary search in error prone. Some of the common errors as follows. Off by one errors. While determining the boundary of the next interval, there might be overlapping errors. Handling of duplicate items. While returning the first item, it might be possible we return a subsequent similar item. Next, numerical underflows or overflows. In a huge arrays, while computing in indices, there might be overflows. Recursive versus non-recursive implementation, which should be considered while designing as recursive takes stack space. Next, catching is spool. So this is the PPT of database and management system, and the topic for the subject DBMS is the topic is a data structure for fast region searches. So yeah, this is the uh, my 80 TED talk for the DBMS, database management system, that is a data structure for fast region services. So yeah, thank you.